Alright everybody, in this series of videos we're going to start covering one of the more basic data structures that kind of we need to have a firm understanding of, which lets us build up some of the more complex data structures that we'll see later on in the class. And that very first, most basic data structure is the linked list data structure. Now, this is a structure that a lot of you should have already had some experience with in your CSC 250 class or in any of your other second level programming classes that you may have had. But just to make sure everybody's got down pat, we're going to go back over it again, some of the details about it, as well as what some of the other data structures are that we can start creating by simply having just a simple linked list. Now, before we start talking about exactly what a linked list is, its interfaces, etc., we need to take one little quick aside and kind of talk about what an abstract data type really is, right? Because in reality, all of the things we're talking about in this class fall under this idea of being an abstract data type. Right, so an abstract data type, or ADT, as you're going to see me reference it a lot throughout the class, is basically just a data type that has some pre-described or predefined user operations. And what that basically means is that if we have a abstract data type of say list or stack or queue, there are some set of functions that apply directly to that data type. No matter how it's implemented behind the scenes, we will always get the same behavior out of it. So, for instance, on our linked list, we have this whole idea of inserting data at the rear of the list, right? Or appending to the list, right? The list could be implemented in any number of ways. That's up to the developer of the abstract data type. However, what we expect is that no matter how it's implemented, the data we want to append to the list will always show up at the end of it. All right, so basically this just says we don't care exactly how the job gets done as long as our expected behavior happens, right? And a lot of that will become more apparent as we start working through our various abstract data types. All right, so you can just think of an abstract data type as basically just describing an interface, right? And we use interfaces all of the time. Our cars have an interface, right? In order to operate our cars, we use the steering wheel, we use the gas pedal, we use the brake pedal, right? We don't necessarily know what's all happening in between us and the wheels actually turning on the car, but we don't really care, right? Because we have this pre-described interface to us. We know exactly how things work. If you get in one car, you can drive another car. It doesn't really matter what's in between, whether you have a gas engine, diesel engine, electric motors, etc. It doesn't matter to us. We still have the same interface, right? So that's kind of the same idea with abstract data types. And what we'll see is that typically most of these abstract data types that we're going to talk about and implement in this class are basically just combinations of lots of either concrete data types such as ints and floats and chars, or other abstract data types, right? So we could use a list and a stack and a queue and merge them all together in some way to generate some other abstract data type, which we will actually do in this class. All right, so remember, just think of abstract data types as something that is giving you an interface, and then it is up to you to actually implement that interface to get the expected behavior out of it, right? So, as I had mentioned, one of the first abstract data types that we're going to talk about, and that you should already have some familiarity with, is the list abstract data type, right? And a list is exactly what it sounds like. It's some method or some data type that lets us hold a list of data. You insert an item, then you insert another item, etc., and it all goes into this list. And then you can search that list to find the data, you can reorganize the list, you can remove things from the list, etc. as you go, right? So it's pretty straightforward. It's exactly what you would expect, right? So in computer science terms, our lists are usually going to be made up of things called nodes, right? Each entry in our list is a node, right? So if we wrote down on a piece of paper, right, that we had a to-do list, right? Get groceries, do laundry, take out the dog, etc., right? This is a list of items or a list of things we want to get done. And each one of these, if we were putting this into a list abstract data type, would be a node in that list, right? So each node is just the individual thing in the list. If we look at our little infographic down here, we can see that, pseudocode-ish, we create a new list and then we start appending items to that list. All right, so we appended ages 55, 85, and 66 to the list, and they just, because we were appending them, that adds them at the back. We could then go ahead and print off our list, which would just print off all the values that you would expect to find in the list. And then we could even go ahead and we could start removing things from the list. So for instance here, they removed the age 88 from the list, and now our list just contains 55 and 66, right? Conceptually, these things are pretty straightforward. What we'll see is that once we start implementing them, that's when things get a little touchier, because we have to start working with pointers and memory, and that's kind of where the hard part comes in as we start working with lists. Okay, so what we're going to find is that when I introduce a new abstract data type to you, usually most of these abstract data types are going to have a predefined set of operations that we can perform on them, right? This is kind of a standardization process just to make working with them easier, right? So if I wrote a list, you wrote a list, and Jim over there wrote a list, we could all implement it in any way we saw fit. We could have 3 different implementations of a list, but all 3 of us could swap our list classes, and we would all be able to use them because we are all using the exact same interface. And that is the most important part, is that the interfaces are the same across all of the ADTs, right? We need to have this standardization so that anybody can use them without having to worry about how they're actually implemented. So what we can see here is that some common operations for our list abstract data types are going to be things like appending to the list, prepending, right? Putting stuff on the front of the list, putting stuff on the back of the list. We could insert after a specific node in the list. We can remove a specific node. We can search for a node. We can print the list in reverse. We can sort it. We can check if it's empty, and we can get the length of it. Right? These are the most common list operations that we'll have to do. And often what we'll see is that we'll implement these in various different ways, but no matter what the implementation is, we should get the same answer back again. All right, so with that, we're going to pause this video, and then we'll go into the next spot where we will start talking about some of the list operations, and we'll start looking at those list operations in actual code.